They are innovators, game changers, people pushing themselves, moving us all forward. They are the next scientists, musicians, poets, the next makers, dreamers, teachers, and geniuses. They are the next list.
3, 2, 1, 0, ignition, liftoff.
Welcome to The Next List. I'm Dr. Sanjay Gupta. This week I'd like to introduce you to a real-life asteroid hunter, Ed Lu.
I feel like we've been offered the chance to positively change the course of humanity. How can you turn that down?
Ed Lu's the ultimate modern-day explorer, probing all that is unknown, from outer space as an astronaut with NASA.
Okay, that's complete.
To deep sea with autonomous robots.
I think he's a venturer, a futurist, an explorer.
But right now, Ed's biggest and most urgent mission is to build a space telescope that will protect the Earth from asteroids.
A 1-kilometer asteroid, if it were to hit the Earth,
would wipe out civilization. You gotta find them before you can protect yourself from them.
Now, you may not think the Earth needs protecting from asteroids, but then again, neither did this guy. I'm Dr. Sanjay Gupta, and this is The Next List.
My name is Ed Lu. I'm a former NASA astronaut. Now I'm the CEO of the B612 Foundation. The B612 Foundation's ultimate mission is to protect the Earth. And the way we're going to do that is to find threatening asteroids before they find us, because they do hit Earth, and they will again in the future unless we do something about it.
Asteroids hit the Earth all the time. Really small ones are just the shooting stars you see when you look up in the sky. Larger ones, like the one that hit about 100 years ago in Tunguska in Siberia, those hit about every couple hundred years. That wiped out an area about the size of the San Francisco Bay Area. So there's about a 50% chance in your lifetime that another explosion of that size is going to happen somewhere on Earth.
The basic idea that we're working on is that we actually have the technology today to deflect asteroids if we have adequate warning. By adequate warning, we mean decades in advance. And the problem is right now that nobody is really doing a comprehensive map of all the threatening asteroids. And so that is our goal.
They'll say, look, the chances are small. We understand the concern, but just such an unlikely thing to happen, at least, for the foreseeable future. Then what do you say to that?
Yeah, you can play roulette all day long, but eventually you get 00, right? And that's our point, is that this doesn't need to be a gigantic government program where we're talking billions of dollars. We're talking about building one spacecraft. Well, look at the dinosaurs. Do we want to go the way of the dinosaurs?
The asteroid that killed off this guy was about 10 miles across. On the day that it hit, it carved out a huge crater, and all of that rock falling back to Earth heated up the atmosphere to about 500 degrees. So what that did was set fire to everything on Earth worldwide. And everything burned on Earth that day. And we know this because we actually have the fossil record of this.
If you look at this rock here, if you go anywhere around the world and dig down to the right level, you'll find a layer of dark rock like that. It's called the KT boundary. It's the same layer anywhere around the Earth. So something happened worldwide, right? And it corresponds with the end of the dinosaurs. Below this, there are fossils of dinosaurs. Above this, there are no fossils of dinosaurs. NASA has actually been discovering asteroids. They have funded, over the last 20 years, a search for the very largest of asteroids.
so they did a good job, you say, of tracking the very big asteroids. But these smaller ones that could cause a huge problem, what's happening with them?
Not much. They have never been able to fund a search for smaller asteroids, ones that might only wipe out a continent or might only collapse the world economy for a century or so. Something like that we're not looking for. And to me, that seems crazy. So this is what we are trying to protect.
It's a nice view. This is the view you had from when you go up?
Yeah, somewhat like that. It's a little higher up than I was. So if you look at the green line, that's the Earth.
Right.
And you can see the other planets with the sun in the middle. This is the orbit of every single known asteroid in our solar system.
Swarming around.
Yeah, it's a busy place. So the outer part, this outer donut, is called the asteroid belt. The intersection, these asteroids are called near-Earth asteroids because they come near Earth. And you can see a lot of them are whizzing past the Earth. Using our telescopes on the ground, we've only surveyed about 1% of the volume of space. The real solar system has about 100 times, therefore, more asteroids than you see right now. These are the 10,000 known near asteroids. The real solar system looks like this. That's about a million near-Earth asteroids that are larger than the one that hit in Tunguska in 1908. That means we've only found about 1% of them. The other 99% are currently out there but unknown. Here's an interesting way to think about it. Let's look at asteroids of 100 megatons or larger. Again, that's sort of 5 times bigger than all the bombs used in World War II.
Right.
And there's about a 1% chance that that's going to happen in any given person's lifetime. That is also about your chance of dying in a car accident. It's about 1%.
Wow.
So, I'll ask you, do you wear a seatbelt?
I do.
Why? It's only 1% chance in your lifetime that you're going to get hit and killed by a car.
Yeah.
Why would you do that? It's not big odds, right?
It's not. But I do everything I can to try and protect myself.
Okay. So, who's protecting the Earth?
Up next, meet the Sentinel, Ed Lu's astonishing telescope that just might save the world.
The plan of the B612 Foundation is to build a space telescope. It's called Sentinel. It'll launch in 2018, and it is going to orbit the sun. This is the Sentinel Space Telescope.
So that's it. Mm-hmm. And that's basically the size of it there?
Yeah, the real one is about the size of, say, a delivery truck. So it's about 23, 24 feet tall, and it's about 2,600 pounds.
It's got its back to the moon, and it's constantly...
Or back to the sun.
I mean,
yes,
back
exactly.
to the sun, rather, and it's constantly surveying everything around it.
Exactly. Because, as you know, it's hard to look with a telescope in the direction of the sun. What you always want to do is have your back to the sun. The nighttime sky is in the opposite direction of the sun. Now, the challenging thing about the Sentinel mission is that it is going to be quite far away from Earth. It will orbit the sun, so that means that its distance will vary from the Earth, but it'll range between 30 million miles at its closest to about 170 million miles from Earth at its furthest. That's about 500,000 times further from Earth than the Hubble Space Telescope. So we've got some challenges there, but we think we know how to do that. In fact, we can send probes to Mars, we can do this too.
So it can basically see anything that might possibly be a threat to the Earth.
That is exactly right. And what it's going to do is going to look at infrared light. This is what the sky looks like in infrared, which is basically heat. Asteroids are very, very dark. They're almost black, and therefore they glow in infrared because they're warmed by the sun. And so if you look in infrared, you can spot the asteroids because those are the moving objects that are bright in infrared. And over a 6.5-year period, it is going to scan Earth's orbit multiple times and map all the asteroids across Earth's orbit because those are the asteroids that could hit Earth. So it's going to track about 500,000 asteroids. So each month it's going to discover about 10,000 asteroids.
Each month, 10,000?
Each month, yes. So which is more than all other telescopes throughout history have combined to discover. So it'll do that every month. One of the innovative things that I think we're doing is that we are funding this privately. We're a nonprofit foundation and we're funded by private donations. That does not mean that we don't have some government involvement because NASA is, for instance, a partner of ours. NASA is going to provide the communications and tracking of the spacecraft because they have those facilities already built. And in return, we will make all the data publicly available. So our contract with the world is that as we find and discover these asteroids, all that data is open.
I think we may be opening a frontier for a new way of doing these deep space missions. And nobody's ever done one with private investment, with philanthropy.
I mean, if you look at the cost of building something like a spacecraft that could actually find all these asteroids,
What are we talking about here?
a few $100 million. Universities raise that all the time to build a new chemistry building, right? Or art museums raise that all the time to build a new wing. That's the kind of scale you're talking about.
So how's it going? Because that's what you're doing now. I mean, you're trying to raise that money.
It's going really well. We announced publicly just this last year, and we've raised quite a bit of funds, and we've been moving.
Ed Lu is at the helm of this.
Right.
Is he the right guy?
Absolutely. Ed is terrific. He's a great salesman, and now you got to recognize that this is not just a technical issue. There's this whole sea change going on in space now where private enterprise is doing a lot of really incredibly bold things in space.
I feel like we've been offered the chance to positively change the course of humanity. And how can you turn that down? I mean, if you are lucky, once in your lifetime will you ever get a chance like that. And so we feel very blessed that we are here at this right time when we can do this.
So what happens if Ed Lu's telescope finds a massive asteroid headed toward Earth? Wait till you see what he's invented. That's next.
So how do you deflect an asteroid?
Earth is a moving target. All you got to do is get this asteroid to show up at the collision point either a little bit early or a little bit late. When I was with NASA, I invented with another astronaut, a guy named Stan Love, one of the means of deflecting asteroids. It's called a gravity trap. And all it is a small spacecraft that hovers near an asteroid. And if you hover near something, as long as your jets aren't pointed at it, you can actually slightly tow an asteroid, a very, 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 very tiny amount. But that's all you really need over a period of months to change an asteroid's trajectory enough so that you can cause it to miss the Earth. I learned a lot at NASA. It has helped me as we set up the B612 Foundation.
3, 2, 1. We have booster ignition and liftoff of this space shuttle Atlantis.
What was that first mission like?
Oh, that first mission was awesome. You always remember that more than any of the other ones, even though the other ones were great.
Just would like to say that this is it's amazing. I can't believe we're actually here.
It was a space shuttle mission on Atlantis in 1997. And we went to the Mir space station.
Hi, Mom. Hi, Dad.
You could talk to Ed probably for hours and never know that he spent 6 months on the International Space Station. You know, there have been about 525 astronauts, and very, very few have ever spent that much time on the space station. So he's part of a very select group.
I think the highlight of my career at NASA was actually a time of crisis at NASA.
Safety's on everyone's minds since the Columbia shuttle disaster.
On February 1st of 2003, we lost the shuttle Columbia, so 7 good friends died that morning. For the foreseeable future, all space shuttle flights were grounded. The only way into space at the time was the Soyuz. No American was trained to fly, so we were left with this, what do we do? Friday afternoon, the chief astronaut said to me, we're going to give it a try. We're going to put 2 people on the space station, and it's you. So Sunday, I was on an airplane. The normal training flow for a cosmonaut flying as the co-pilot of a Soyuz is typically a year or so, and we had 9 weeks. So the only way to do that was for me to basically go morning till night, 7 days a week. Both Yuri and I fell asleep on the launch pad. That's how tired we were. Well, obviously the first few weeks were difficult, and I think we're ready. Myself and a Russian cosmonaut named Yuri Melenchenko launched on April 26, 2003.
Have engine start and lift off.
And we spent 6 months together on the space station, just the 2 of us. I remember specifically a couple hours after launch where we were now in orbit in the little capsule. And I remember thinking to myself, I'm looking out the window and thinking, how crazy is this? I'm a Chinese-American kid from upstate New York, and I'm flying a Russian spaceship now. It's crazy that I ended up in that spot. I was a nerdy kid. I grew up in a small town called Webster, New York, which is outside of Rochester, New York. I was always interested in science. My dad was an engineer, and I always wanted to be a scientist or an engineer, but I loved anything that flew and anything that had to do with the skies. I love airplanes more than just about anything except my family, and depends on whether or not my family is present or not, what I say. So this is the airplane my wife refers to as the Mistress, and it is the airplane I get to fly on weekends. This is an old flight suit from my STS-106 days. STS-106 was my second flight. That's our patch. My fascination with space when I was a kid really had to do with the space program. Watching the astronauts land on the moon. And one of the great pleasures I have now is that I'm friends with many of these guys. And in fact, with the B612 Foundation, I co-founded that foundation with Rusty Schweikart, who's been kind of a mentor to me. And he was the first pilot of the lunar module on Apollo 9.
Ed is a big thinker, and because of his work ethic and the education that he's gotten, the way he thinks, he literally has the opportunity to act on that big stage.
He's just a very humble person, and he doesn't feel a need to prove that he's better or whatever to anybody. He's just very comfortable about who he is. And I think that's why he's able to do all these things that he does, is he's not trying to prove to anybody that he's anybody. He's just trying to be happy and fulfill what his dreams are.
You have a family, your parents obviously, but also your wife and kids.
Mm-hmm.
Were you on any missions after you got married?
No, actually, on my last mission, I was engaged but not yet married.
Would you still go up with a family? I mean, or do you worry about safety?
If I had a chance to go up again, I think I might like to do that. Obviously, this would be a family decision now.
Mrs. Liu is listening. What is
and
she thinking?
She does have a say in this. As we say in our family, you know, we have an almost equal partnership where she gets 51% of the voting block.
Right. I'm familiar with that.
Yeah.
Ed Liu isn't just about asteroids. He's also exploring the deep sea with robots unlike anything you've ever seen before. That's next. Welcome back to The Next List. I'm Dr. Sanjay Gupta. Hunting asteroids isn't Ed Liu's only passion. He's also got his fingers in other companies that are focused on exploration. Everything from a revolutionary new way to create 3D maps to autonomous ocean robots.
We're here at Liquid Robotics today, and we build ocean-going robots that swim on their own and take data all over the oceans, in every ocean around the world. My real job here is as an instigator. I'm Chief of Innovative Applications here at Liquid Robotics. These things are just like little satellites. They transmit data up through satellites. They swim on their own. They're powered by waves. You can change instruments on this. You can put whatever instruments you want in it. So, for instance, you can measure water temperature. You can get up to the minute weather, winds. It can measure waves, oil in the water, if you're looking for oil leaks, whatever you want to put inside it. I think this is pretty cool because it is changing the way we measure conditions on the oceans. Right now, if you want to measure the amount of carbon dioxide in the water in some location, you have a couple of choices. You can measure it from space, or you can send a ship or place a buoy there. All of that is hugely expensive. Now, the other way you might do that is to deploy these cheap fleets of robots. Right behind me is the control center where we steer and control our fleets of robots around the world. It's a lot like mission control in Houston. There's huge similarities between ocean and space. Vast areas, relatively unexplored, and they're environmentally tough. And so the way you go about exploring them is actually kind of similar.
I think he's an adventurer, a futurist, an explorer, not only of space, but the horizon of technology as well.
Right now, we're at the offices of Hover, which is a small startup here in Los Altos in Silicon Valley. I am the CTO. My role here is to stay out of the way of all these guys who are actually doing work. What Hover is a company that makes three-dimensional maps from overhead images, street-level images, whatever images you can get. And we can turn those images into three-dimensional models that you can fly around, you can see, and you can update so that they are constantly updated using all this imagery that comes in. This company was started by some Navy SEALs and the Marine intelligence officer who was in Iraq. And basically what they did was set out to give our troops on the front lines a tool that allows them to understand what they're about to get into.
Whether it's military or other sorts of tactical environments like law enforcement, they're trying to get a sense of what that place is going to look like before they get there.
This is AJ Altman, who is our founder here at Hover. I'm going to just ask AJ to cross the street without getting killed and take my picture in front of the building here. On three, wave. So we just took that picture outside, and now what we show you is right here, we've updated our model of Los Altos. And there we are. There's me being held up by the CNN cameramen. But you can see that that image that we just took from across the street is now part of our three-dimensional model of Los Altos. Real-time updating of a three-dimensional map. I'm trying to get us to look at things like where can we go with this technology, what can we do with it, and provide a little bit of how the space has evolved, because I used to do similar things at Google. In 2007, I came to work at Google
where I ran advanced projects, where we did everything from the imaging systems for Google Street View to Google Earth to Google Maps to energy projects like Google Power Meter.
But when you look at EdLu, you hear things like liquid robotics, 3D imaging,
Right.
and obviously, B612.
Right.
What's the unifying theme for EdLu?
I think that Ed is fascinated by the horizon, by what's over the next hill. Could be exploring space, it could be a new vehicle that paddles its way out into the ocean, it could be finding threats to the Earth.
I think we're living in a really special time right now. For 4.5 billion years, this planet has been hit by large asteroids, thousands of times. And we've reached the point where we, as a species, have figured out the technology that we could actually stop that process on this planet. I mean, think about it. We're talking about changing the actual evolution of our solar system such that the third planet is no longer hit by asteroids. I feel like we are lucky to live today. We are seeing great technical progress. We are seeing things that you could never have dreamed of even 10, 20 years ago, and we're part of it. That's pretty profound.
EdLu won't stop until his space telescope has found the asteroids headed toward Earth. It's a mission few people would even dare to attempt. And that's what earns Ed a spot on the next list. I'm Dr. Sanjay Gupta. Thanks for joining us. We'll see you back here next week.